this is the e, and I need to simplify this expression, and I'm going to, like we said, multiply what's outside. What is outside? Not just the c, not just the b to the 3, not just the a to the 2, it is the entire thing. So the entire 2a to the power 2 b to the power 3c must be multiplied with every term inside the bracket. Once again, what is going to cause you to make mistakes here if you forget about your signs and the invisible ones of your exponents? Okay? Let's see how this works. If I multiply this term, you could say the factor with the first term inside the bracket. What do I get? How do I multiply that? I'm multiplying all of this with 2a. So, same as before, I multiply the numbers with the numbers and the letters with the letters. Numbers with numbers, variables with variables. So what is 2 times 2? So that's the 4. 8 to the power 2 times 8 gives me 8 to the power 2 plus 1, which is 3. B to the power 3 times, oh, there's no b. So that means b to the power 3 just comes along. Yeah?
Yes, sir.
B to the power 3 does not have a partner here to multiply with, so he will just stay as he is. C multiplied by, oh, there's no c either. So c just comes with. Are we together?
Yes, sir.
So that's the first multiplication done. Then second, I will multiply with 3b squared. So that will be 2 times 3, which is 6. 8 to the power 2 times, there's no a. So 8 to the power 2 remains 8 to the power 2. B to the power 3 times b to the power 2 gives b to the power 5. C to the power 1 times, there's no c. So c remains c. Last one. I'm multiplying 2 now with what number here? The negative 1 that's in front of the c to the power 10, so it's 2 times negative 1, which gives me 2 times negative 1 gives me 2 times negative 1 gives me. I need to hear a unanimous answer from the entire choir. Negative 2. A unanimous negative 2. 8 to the power 2 times, there's no a, so 8 to the power 2 stays 8 to the power 2. B to the power 3 times, there's no b's either, so b to the power 3 remains b to the power 3. Then c to the power 1 times c to the power 10 gives me c to the power 11. Now, I need to check, I have multiplied this out, meaning there's no more brackets, it's been expanded. I still have 1, 2, 3 terms. I still need to check, can I simplify further by adding like terms? So, are there like terms in this expression?
Yes, sir.
Really?
I don't know, sir.
How do I determine like terms? What are like terms? How do I know? What are the conditions for terms being like terms? Bases are the same? The basis must be the same and the exponents. 2 conditions. In other words, to put it plainly, same letters, same exponents. If you have the same letters but the exponents are different, they are not like terms. So what do I have here? Same letters, but all the exponents are different. Here I've got the same exponent for A, but my B's are different, my C's are different. That immediately rules it out as like terms. This is very important, because you're going to end up adding the wrong stuff. So, I have none of these terms with the exact same letter and the exact same exponent for each of the letters or variables. Do you see that? The A's here are different, the B's are different, the C's are different. So can I continue? No, I'm done. I'm done. Can we go on? Must we not go on? No. Must I do it? Alright. Let's start with the multiplication, eh? Remember, I'm applying the distributive property. I'm multiplying what's outside of the bracket with every term inside the bracket. Okay? Thank you. Thank you. How many terms are inside the bracket? How many terms are inside the bracket? 3. 1, 2, 3. How do I know? Because they are separated by pluses and minuses. Okay? 1, 2, and 3. The distributive property allows me to multiply what's outside of the bracket with every term inside the bracket. So I did that. So that's the first multiplication. Gives me 2 times 2, which is 4. Then I multiplied all the letters together, all the bases that are the same. A to the power 2 times a gives me a to the power 2 plus 1, which is a to the power 3. B to the power 3 cannot be multiplied with another b in this term because there are no b's in that term. So b to the power 3 remains b to the power 3. Is that clear to everyone?
Yes, sir.
Payment? C cannot be multiplied with any c here because there aren't any c's in the first term, so c will be rewritten as it is. And that concludes the multiplication for the first term. Do we see that? I have now multiplied what's outside with the first term. It's done. Then I do it for the second term. So it's plus. I have 2 times 3, which is 6. Then I've got a to the power 2 times, there's no a here. So a to the power 2 remains a to the power 2. Then I've got b to the power 3 multiplied by b to the power 2, which is b to the power 3 plus 2, which is 5. I'm applying the law there. Then c to the power 1 times, there's no c in the second term, so c to the power 1 just comes along as he is. Then the last term, I do the same thing. I'm doing the same thing 3 times. Okay, so I'm doing this now for the last term. 2 times negative 1 gives me the negative 2. Then again the letters. A to the power 2 times, there's no a, so a to the power 2 stays a to the power 2. B to the power 3 multiplied by, there's no b, so b to the power 3 stays b to the power 3. Then lastly, c to the power 1 multiplied by c to the power 10 is c to the power 1 plus 10, which is c to the power 11. So this is not, I don't think it is complicated, it's just a matter of keeping track of what you're doing. Right? Especially when there's a lot of letters involved. So you do it step by step. You do it for the first one, then the second one, then the third one. Are we there?
Yes, sir.